Everyone, thanks for coming back to my channel. Today we're going to be studying integration by parts. This is an important tool in our toolkit. Hopefully by the end of this lesson you'll see why. We also call this IBP. And we have this catchphrase, this buzz phrase that we use when we talk about this technique. We say that we trade a derivative in g of x for a derivative in f of x, right? So that you understand this catchphrase, I'm just going to give you the formula. The formula is the integral of f of x g prime of x dx equals f of x times g of x minus integral of f prime of x g of x dx. So now we see how this phrase works, right? On the left hand side we have the integral of f of x g prime of x. On the right hand side, no g prime of x, just f prime of x and f of x and g of x, right? So we've successfully traded a derivative in g of x for a derivative in f of x. Right? Now sometimes we write this formula a little bit differently. Actually, in practice, this formula will be more helpful probably. Right? So we write this as the integral of u dv equals u times v minus the integral of v du. For this to be valid though, we have to make some definitions. We got to show how we got from here to here. So what we've done is we've set u to be f of x, v to be g of x, and so du equals f prime of x dx, and dv equals g prime of x dx. And if you need help getting these du's and dv's, I would check out my U Substitution video. Right? So now let's just kind of mentally check. So we have this integral of u dv. So u is f of x, dv is g prime of x dx. That's this left-hand side of this first formula I wrote down. Then we have u times v, f of x times g of x, obviously. And then this integral of f prime times g of x dx, same as v, which is g of x, times du, f prime of x dx. So we're done. So now I'm going to show a quick proof about how we got this formula. That will help you understand how we got this formula. It might not really help you do this in practice, but then we'll do some examples. So to make the proof a little less notation heavy, we're going to set f to be f of x, and f prime is f prime of x dx. Okay? So the proof just follows from the product rule for derivatives. So let's say we wanted to find d by dx of f times g. Right? What is this? It's f prime times g plus g prime times f. Okay? So now we're going to integrate each term. Integral, integral, integral. Right? So now using the fundamental theorem of calculus, we know that the integral of a derivative, basically these guys just cancel. Right? And that makes sense. The integral, especially an indefinite integral, is called an antiderivative. Right? So it makes sense that if you take the antiderivative of a derivative or the derivative of an antiderivative, that they cancel. Right? So what do we have now? We have f times g equals f prime g plus the integral of that, and the integral of g prime f. So now look up ahead. We have this fg, so we're obviously on the right track. But what do we want? This left-hand side has f of x times g prime of x. So we look through these terms and we see, oh, here it is. Here's g prime of x times f of x, right? So we just have to solve for this now. So we just subtract this guy from each side, right? So we get f times g minus the integral of f prime g equals the integral of g prime f. And now we can just rewrite this so that it's in this form. We can put this on the left-hand side, right? So we flip the equation. So g prime f equals fg minus the integral of f prime g. And that's it. That's our proof. We have this formula right here. So now let's just do a quick example to kind of see how this is done. We're going to integrate ln x dx. There's a little trick to doing this one, and the trick is this. So we're going to set u to be ln x, right? And so what's our dv? So you can set your dv to be 1, or you can set it to be dx. I'll set it to be dx. So we'll say that dv equals dx. Okay? So now you can see how we do this in practice. Usually we choose our u, and then we do what I call a backwards U substitution. We find our dv, and then we integrate dv to find v. So let's do that. Let's integrate dv. So if we integrate dv, we get the integral of dx. So let's do this. We'll say dv equals dx, and we'll only integrate both sides, right? So the integral of dv is v, and the integral of dx is x plus c. But we can choose this c to be 0. You can ignore this. So we have v equals x. Okay? Now let's find du. Du is 1 over x dx. Again, check out my U substitution video if you need some help understanding that. So now we just plug into the formula. It's relatively simple now. We've done all the hard work. So u times v, u is ln x, v is x. So the first term is x times ln x minus the integral of v du. What's v? It's x again. And what's du? It's 1 over x dx. So now we get this cancellation here between x and 1 over x, right? So this is just x ln x minus the integral of dx. What's the integral of dx? As we saw over here, it's x plus c. And now we don't ignore the c. So the final answer is the integral of ln x dx is x ln x minus x plus c. Where I've just kind of absorbed this minus sign into the c. It doesn't really matter. The c is a constant, right? So that's it. That's that whole question. So now I want to show you a quick note about why this is useful. And this is useful because it can be used as a recursive formula. So I'll explain that with an example. Let's say I want to compute the integral of x squared times cos x dx. Right, so now I look at this. I don't know what this integral is. I couldn't find this antiderivative off the top of my head. But I do know the integral of cos x. Right? That's easy for me. So how can I get rid of this x squared term? The way I get rid of that x squared term is by using IBP multiple times. So I'm going to set u to be x squared. So now when I take the derivative, du, I'm going to get 2x dx. Right? So when I plug into the formula now, I'm going to have to deal with 1 less power of x. Instead of x squared, I'm going to have to deal with x. We'll see. So our dv, we choose to be cos x. We integrate to find v. So integrate both sides. V is sin x. So again, now plug into the formula. So the integral of x squared cos x dx is u times v, x squared times sin x, so x squared sin x, minus the integral of v du. V is sin x, and du is 2x dx. So I'm going to put the 2 out here. So x times sin x dx, right? So now we have 1 less power of x. So now again, I don't know what the integral of x sin x is, but I know the integral of sin x, hopefully. So let's write down our x squared sin x again, right? And then use another U substitution. I'll use the same u's and v's. So we'll set u to be x, du will equal dx. 1 dx, right? Take the derivative of x, it's just 1. And we'll set our dv to be sin x. And now, if I'm careful, I'm pretty sure v is now minus cos x. If I'm wrong there, you're off by a minus, so it doesn't really matter. Look that up. So now we finish the second integral, right? So minus 2 times, put some big brackets. Again, u times v, x times minus cos x. So we'll do minus x cos x, right? Minus the integral of v du. Minus cos x times du is just dx, right? Simplifying everything, just bring this minus in and cancel with these guys, right? We're going to get x squared sine x plus 2x cos x minus cos x dx. Cos x dx. And again, the integral of cos is sine x. So we're going to get x squared sine x plus 2x cos x minus sine x plus c. That's it. So thanks for listening. Hope you learned something.